In this video, we'll look at curve sketching a rational function using derivatives. Normally, you'll take the derivative on your own. These are a little bit harder derivatives, so I've done them for you. The equation is y equals x squared plus 2x plus 1 over x squared plus 2x minus 3. That's what we're going to sketch. But to do that, we'll also look at the derivative, which is, when you take it, negative 8x minus 8 over x squared plus 2x minus 3 squared. And the second derivative is 24x squared plus 48x plus 56 all over x squared plus 2x minus 3 to the power of 3. Okay, we'll start with the original function here. This lets us find the zeros by setting it equal to 0. And we get 0 equals x squared plus 2x plus 1 all over x squared plus 2x minus 3. When we set it equal to 0 and we solve, to solve, we multiply both sides by this denominator, which essentially gets rid of the denominator. Multiply both sides by x squared plus 2x minus 3, and you just get 0 equals x squared plus 2x plus 1. What do you do with that? Well, Bergman technique, factor it. What multiplies to 1 and adds to 2? The numbers are, of course, 1 and 1. So you get 0 equals x plus 1, x plus 1. And so x plus 1 equals 0. Or x plus 1 equals 0. Do you have to show both? Nah, because they both give you an answer that there's a 0 at x equals negative 1. Now we know where one of the zeros is. In fact, that's the only 0, because otherwise we would have found more. The first derivative tells us where we've got our max-min, our critical points. So our max-min occurs at this derivative where it equals 0. So we have negative 8x over 8. Sorry, negative x minus 8 over x squared plus 2x minus 3 all squared. Make sure my fraction goes the whole way. And once again, I multiply both sides by the denominator. X squared plus 2x minus 3 squared times 0 just leaves 0. And multiply it on the right-hand side, it cancels out. And you're left with a nice, easy equation. Negative 8x equals negative 8. So 8 equals negative 8x. X equals negative 1. Interesting. At that 0, we know we're going to also have a max or a min. I'll write here max min, even though you don't have to write it there, it's above. And finally, we're going to look for our points of inflection. Our points of inflection occur where the second derivative, 24x squared plus 48x plus 56, all over x squared plus 2x minus 3 cubed equals 0. Well, again, multiply the denominator by both sides, and you get 24x squared plus 48x plus 56. And now we can common factor. 0 equals, and 8 comes out of that, and we get 3x squared. What's 48 divided by 8? Feel free to use your calculator, won't judge. You get 6. 56 divided by 8 is 7. And you get this. We could try to factor that. What multiplies to 21 adds to 6? Nothing. So we're going to have to do quadratic formula to solve that. I find I make less mistakes when I identify the a is 3, the b is 6, and the c is 7. So x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is negative 6 plus or minus 6 squared minus 4 times 3 times 7 all over 2 times a, which is 6. Okay, x equals negative 6 plus or minus the square root. I'm going to get the calculator out now. 6 squared is 36. What's 36? Aha, I can see where this is going. I made a typo there. 36 minus 4 times 3 times 7. Which is the square root of negative 48. And that's important because we can stop there. This is undefined. You can't square root a negative, which implies no points of inflection. Whatever the shape of this graph has, there won't be any points of inflection. Okay, let's go down here and make our table. Our table includes all our zeros, our max and min, our points of inflection. Oh, but we should also do the properties. This is a rational function. Right now, up till this point, it's been just like polynomial functions, but we also have to check the asymptotes. Where is there a horizontal asymptote? Well, it's the coefficients. If the degrees match, it's the coefficients of the matching degrees if they're the largest. Or you can just think, what happens when x gets really big? When x is 1,000, you'd get like 1,000,000 over 1,000,000. These would hardly matter. This would be, sub in x is 1,000,000. You would get, what's 1,000,000 squared? A quadrillion, no, a trillion. 1,000,000 squared over 1,000,000 squared is a trillion over a trillion. This is just like spare change. It won't matter. You're still going to get basically 1 over 1. That's why the horizontal asymptote, which I need to write as an equation, so I'll put a colon here. The horizontal asymptote, as x gets really large, y approaches 1. What's the vertical asymptote? That's wherever the denominator equals 0. So I'm going to have to factor the bottom there. X squared plus 2x minus 3. What multiplies to negative 3 and adds to 2? The numbers are 3 and negative 1. And so I'll put an arrow down here. So I get x squared plus 2x minus 3. I guess I didn't need to rewrite that. Equals x plus 3, x minus 1. And so this is going to be in the denominator. What would make this denominator 0? The vertical asymptote is negative 3. That's one of our asymptotes. And what would make this denominator 0? A 1. And x equals 1. Does the graph have any holes? It would have holes. Whoa, I should have checked for holes first. The top factored into an x plus 1, x plus 1. The bottom's x plus 3 and x minus 1. Yeah, I really wish I'd done this first to check those holes. But it's okay, I'm lucky. There weren't any holes. Otherwise, I'd have to erase my asymptotes because there's no shared factor on the top or on the bottom. So now I know horizontal asymptote, and I know the vertical asymptotes, and I know there's no holes, so I can write none or NA. And now I'm ready to make my table. My table is going to consist of x, f at x, f prime at x, and f double prime at x. Let's take my trusty ruler. It's never let me down. I'm going to make a table. Doesn't have to be beautiful, but make sure it's legible. And I'm looking for 5 spots in particular. Those places we've identified just a moment ago. I'm going to need a little bit more lines there. So I get, in order, what are my important points? Well, I have a vertical asymptote at negative 3. I'm going to leave a space there. I'll show you why in a second. And then I have max or min at negative 1. And then I have another vertical asymptote at 1. Why did I leave a space here? These are my only important points. I didn't have any points of inflection. Here's my max or min, and here are my vertical asymptotes. What do I need this spot for? Is I need to just check a value on either side of these asymptotes. So I'm going to choose something easy, just like negative 4. And on the other side of this asymptote, how about positive 2? What's the value of f at x or f prime at x? You can't do it. This is a vertical asymptote. So I'm going to put vertical asymptotes. I got them over here. Down these columns, because I don't need to evaluate them. It's impossible. It's a vertical asymptote. Okay, what else? I know that f prime at negative 1 was 0, so a 0 goes here. And that means at this point you're going to have a flat tangent. And then I have zeros at negative 1, so that means there's a 0 here. And I'll write down that this is a 0. Okay, so what to do? I got to find out what the value is at negative 4. In fact, I don't really care about the value. I care if it's positive or negative. Sub in negative 4. When I sub in, I'm going to put this down so you can see it. Negative 4 squared is 16 plus 2 times negative 4. That's negative 8 plus 1. So I get 9 over, and then sub in negative 4. I get 16 again, and then negative 4. So minus 8 minus 3, and I get 9 over 5, which of course is positive. So this means it's above the x-axis at this place. How about at 2? What's f at x when x is 2? So that I can maybe do in my head. 2 squared is 4, plus 2 times 2 is 8, plus 1 is 9 again, but for a different reason. I get 9, and on the bottom, 2, I mean it's the same, but we'll see here, when you square 2 on the bottom, you get 4. 4 plus 2 times 2, that's 8. But then take away 3, oh, you get 5 again. But once again, it's positive, so it's above the x-axis. Okay, we're going to look at the chart, but only once it's complete. I got to look at what's f prime at x at -4. So now I'm subbing into this equation here. What's f prime at x at -4? And again, I don't really need the value. I just need to know what's the sign. -4, when you sub in -4 here on top, you'll get negative times a negative, which is a positive, 32. 32 minus 8 gives a positive. And on the bottom, what do I have? I sub into this, but you know what? It doesn't even matter what I sub in. Even if I get a positive or negative, I'm going to square it, which gives me a positive. And so that means when I sub in -4 to that equation, I get a positive, which means at this point, -4, I'm going to have a slope like this. That is, my tangent slope will look positive. How about when I sub in 2? You sub in 2 on the top, you'll get -16 minus 8. That's a negative. And on the bottom, doesn't matter. Subbing in anything to a squared gives a positive, which is, of course, going to be a negative. And now, how about the second derivative? What happens when I sub in -4 into this equation? Whoa. I'm going to need to do some math on that one. So, a negative on that one. Yikers. That's going to be some things there. I'm going to have to probably sub it in because it looks like it's going to be close. -4 squared is 16. 16 times 24 is 384. Plus 48 times -4 equals plus 56. Oh, so it wasn't close. I get a positive on top here over on the bottom and sub in -4. So I get 16, and then -4 times 2 is -8 minus 3, which is 5. 5 cubed is a positive, so I get a positive here, which means you're going to be concave up. How about subbing in -1? -1, I'm subbing into this equation again. -1 squared is positive, so I get 24, and then -1 times 48 minus 48 plus 56. That gives me 32, which is a positive, over on the bottom, subbing in -1. So I get +1, but then I get 2 times -1 is -2 minus 3. I get -4, and -4 cubed is going to be -64, a negative, which gives me a neg. So here I'm concave down. You notice below each symbol I'm drawing the shape, which I forgot to do over here. This tangent is negative, so its slope will be like that. And then the second derivative is going to be sub in 2, and I get 2 squared. Well, I can clearly see that's going to be a positive. Sub in 2 here and here, I get a positive on top. On the bottom, sub in 2, it's going to be 4 plus 4, take away 3 is 5. 5 cubed is positive, so I get a positive here, which means concave up. Oh, I have enough to graph. I got my whole table. I'm going to draw my sketch. And it's not a proper graph, so I'm just going to label the key points. Don't forget to come back for the holes in the vertical asymptote. The vertical asymptote's in your chart, but the horizontal asymptote isn't. I have a horizontal asymptote, which I got to label, is at y equals 1. And then I got vertical asymptote at -3. Put that here. That's x equals -3. And notice it's just equals here. Not a not equal to, it's a equals to. And this is the vertical asymptote at x equals 1. And now time to sketch. Okay, what do we got here? For -4, that's on this side. I'm positive. My tangent slope should be positive, and I'm concave up. So that'll look like this. Coming in close to that asymptote, but never quite touching. Then I have a vertical asymptote at x equals -1, so that'll be, let's say, around here. At x equals -1, I'm a 0, so I hit here. and I have a flat tangent, a horizontal, and I'm concave down, which means I gotta look like this and approach the asymptotes. Like that, and approach the other asymptote. I think my scale's off a little bit on this graph, but that's okay. I'm marking the sketch. Don't have to put a scale here. It's a sketch, not a perfect graph. We're curve sketching. And then I have a vertical asymptote at 1. And then at 2, I'm positive with a negative slope. So I'm above the x-axis. My slope is negative, but I'm concave up, so that'll look like this. And I've done it. I've sketched a rational function using derivatives, found the zeros, the max-mins, the points of inflections, but I should have found the horizontal asymptote, the vertical asymptote, and the holes first, made a table, and used the table to make a graph.